Welcome to the next installment of my video lecture series for international economics. And in this particular video lecture, I'm going to be looking at the production function and how that relates to the marginal product of labor. So on the left-hand side here, we see we have a production function for cloth. And all that does is represent what's the level of output going to be as I increase or as I change the number of workers that I use in the production of cloth. And as you can see here, it is upward sloping, number one, because as the more workers that I hire, the greater the level of output. So make sure that you realize that. Also realize that the slope of this line is going to be the marginal product of labor, and as part of this video lecture, I'm going to be deriving what the marginal product of labor looks like given this particular production function. And also realize that this production function exhibits diminishing marginal returns. The thing you have to realize is that we have a fixed amount of capital. The only thing that we're doing here is altering the amount of labor. So we have a fixed capital stock, so K here is going to be fixed and that's going to remain unchanged. But what we're going to be doing is changing the amount of labor and see how that impacts output. And the reason for this is that you have to realize that with a fixed capital stock, as I hire more workers, if I go from 1 to 2 to 3 to 4 to 5, etc., the capital stock remains fixed, which means each worker has less capital available to them to do their job. So if we have a fixed capital stock, with one worker, they get to use all the capital that's available to produce that particular output. And as I increase workers, that capital has to be split amongst higher levels of workers or more workers being used. So make sure you realize that. Now what we want to make sure that you understand is, or I want to make sure that you understand is, looking at this production function, how can we derive what the marginal product of labor curve is going to look like? So what we're going to do is we're going to incrementally, continually increase the amount of workers that we're producing and see how that each of those workers, what impact they have on production. So for example, if I start with no workers, I'm going to have no cloth production. And if I hire one additional worker, so if I move from this point here to this point there, and let me change that just slightly. Here we go. I'll leave it the same, but I'm going to make it a dotted line and place an arrow at the end of it. So I started with 0 workers, but now I'm going to hire 1 worker and see what happens to production. So when I do that, if I go up here, we can see that production has increased by 3. With no workers, output is equal to 0 here. So we have no output. When I hire 1 worker, and if I go up to the production function, that tells me I have an output of 3. So hiring that first worker gives me an output of 3 units. So if I go over to this part here, I go to the first worker, so their marginal product of labor is going to be equal to 1. So now let's continue that process and see what type of contribution each additional worker has in the level of output. So if I go from 1 worker, I hire 1 more worker, so now I have 2 workers. All right? So if I go from that second worker up, and we put an arrow on the end of that, so that worker has moved our production from 3 to about 4, let's say 4.7. So our output goes from 3 to 4.75, so the marginal product of the second worker is going to be equal to 1.75. So if I go over to here, the second worker on the margin is going to give us an output of 1.75. And these are just estimates. I'm just eyeballing it for that purpose. So we can continue along. Instead of having 2 workers, I can hire a 3rd worker. So I can go from this point here over to here for the 3rd worker, adding the arrow on there to show that to you. And then I can bring that point up from there to here, which is roughly equal to 5.9. So that gives us an incremental increase of 1.15. So I've gone from 4.75 to 5.9. So the marginal product of labor for the third worker is going to be equal to 1.15. And let me put that point in roughly there. I can continue along, and I'm going to hire an additional worker. So instead of stopping with 3 workers, I am going to hire a 4th worker. Let me put the arrow on there. And then if I move up from the 4th worker up to that point, it goes to 6.8. So we go from roughly 5.9 to 6.8 for the 4th worker. So on the margin, that worker gives us 0.9. And if we connect all of those points together, and see if I can remember how to do this, we can see that that gives us the marginal product for that for workers in cloth production. You can see the line's not exactly smooth because of the actual functioning of this particular program. But what I want you to illustrate, or what I want you to understand, is how you move from the production function for cloth with a fixed level of output, and how you can derive what the marginal product of labor is for cloth. So let me put MPL C, make that lowercase. Let me save that just in case I have some issues. For some reason, I've been having some errors coming up with this OmniGraph Sketcher. I like this program quite a bit. Unfortunately, the issue is that this program is no longer supported. They actually give it away for free, so I really can't get any of these issues addressed, which is a shame because I really do like this program, particularly for doing some graphical analysis in economics. So make sure you're comfortable with going from the production function to the marginal product of labor. All you do is you look at incrementally, I increase my workforce by 1 unit, and how much does my output increase? So when I go from 0 workers to 1 worker, output goes from 0 to 3. Therefore, that first worker contributes it contributes 3 units of output. And as I hire additional workers, I just add in what is the increase in output for the hiring of each additional worker, and then you get this downward sloping marginal product of labor for cloth curve that you see in your textbook.